All right, welcome to our first unit. Our first unit is mix and flow of matter, and our first topic is matter on the move. So we're going to talk about fluids first. What is a fluid? So fluid is any substance that flows, and it includes liquids and gases. So both liquids and gases are able to flow. That is why they are both called fluids. So examples of fluids would include things like wind, water, the blood, and air. Non-fluid materials sometimes can behave like fluids if they are melted or they are dissolved in fluids. And when we talk about fluidity, this is the ability to flow. So when we talk about the particle model of matter, you've probably learned a little bit about the particle model of matter in grade 7. So we're going to extend on it a little bit more in grade 8. So first, all substances are made up of tiny particles. 2, all particles in a pure substance are the same. So different pure substances are going to be made of different particles. So if we had gold, all of the particles of gold will be the exact same. But if we had silver, they would look like different particles, and they would be different from the particles of gold. 3, the particles have spaces between them. 4, the particles are always in motion, and speed does depend on temperature, the speed of the particles. So if the temperature increases, the particles are going to move faster, and if the temperature decreases, the motion of the particles will decrease. They will slow down. And number 5, the particles in a substance are attracted to one another. And this attractive force depends on the type of particle. Next, we're going to talk about the states of matter. So solid, liquid, gas, those are the states of matter we're going to focus on. Solids, these have a definite shape and a definite volume. So examples include a rock, a sugar cube, salt. Those are all solids. A liquid, this is a state of matter that has a definite volume but no definite shape. So think about if you have a juice box. It has a definite volume, but if you spill the juice box on the floor, it doesn't have a definite shape. It takes on the shape of whatever container it's in. So an example could be juice. An example could be water. Next is gas. This does not have a definite shape and it does not have definite volume. An example of a gas is oxygen. So just continuing here with states of matter. So here we see our solid in this beaker. Notice it just stays as a solid, stays together. It has its fixed shape and volume. Next we have our liquid. It's taken now the shape of this beaker, and notice also it forms this horizontal surface and it has a fixed volume. The gas has neither a fixed volume nor the fixed shape. It's expanded in this case to fill the container. All right, just another diagram here showing the particles now of the solid, liquid, and gas. So solid, we can see tightly packed together, not as much space between the particles. Liquids, they're a bit farther apart. There's more space between particles. And then a gas, much more spread out, and there's much more space between the particles. All right, so just to sum up for each, particles in solids, the particles are tightly packed together. They cannot move around so freely. They can only vibrate. And you can grind up solids into smaller pieces. That way they can start slipping past each other when it's poured. So for example, sugar, salt, flour, detergents, crystals, and powders. But if you take a look at each tiny fragment, it's still a miniature solid. And they're not true fluids. So even though you can pour them, like if you were pouring out flour or sugar, they're still not true fluids. Even though that they can be poured like fluids, they are still not fluids. Reason being is when we pour them out, solids will form a pile when they're poured, and they do not keep flowing apart from each other. Next, liquids. So liquids, the particles can slide around each other. They can still vibrate close together in small clusters, but they will never form like rigid clumps as we saw in solids. The particles of a liquid, they cannot hold their shape, so therefore they will fill a container, they'll take the shape of that container. And they'll always flow to the lowest possible level. That's why I showed this waterfall here, right? It's flowing, flowing, flowing to the lowest possible level here, and then they'll form that level surface when they're at rest. And then gases, the particles are very far apart. There's an enormous amount of empty space between them. They'll take on the shape of the container. If you open up the container, then they're going to fill up the whole room. And gases will not flow to the lowest possible level like liquids. That's because gas particles aren't clustered or packed tightly together. Gas particles are able to move in all directions and sometimes against gravity, and then they can remain suspended. So like I said, if you take the lid off of a container of gas, those gas particles will just start to spread again until they fill up that whole room or maybe that whole building. All right, so gases, they'll always occupy all the space that they can fill. And then plasma, we don't talk about plasma as much, but it is another form of matter in the universe. So solids, liquids, and gases, they're not the most common form of matter in the universe. The actual most common form of matter is plasma. It's a fluid state. It's like a gas-like mixture of positively and negatively charged particles. And then when heated to very high temperatures, the particles collide, they'll break apart into smaller particles, and then they can even start conducting electricity. All right, so for example, we see glowing plasma in stars, the sun, and in lightning. All right, change of state. So this is when the physical state of a substance is transformed into another state. So for example, solids can become liquids through the process of melting, which is also called fusion. Vaporization is the change from a liquid to a gas. Condensation is the change from a gas to a liquid. And freezing, which is also called solidification, is the change from liquid to solid. Sublimation is a change of state that goes directly from a solid to a gas or a gas to a solid without becoming a liquid first. For example, dry ice, a chunk of frozen carbon dioxide, which is a solid, it can gain enough energy and then give off a thick cloud of fog or carbon dioxide gas, and it doesn't go through the liquid phase at all. So that would be sublimation. All right, so this is just a diagram here showing sublimation. Notice here, sublimation from solid to a gas, but it's got another term called deposition when it goes from gas to solid. Evaporation is a slower form of vaporization, and it can occur over a wide range of temperatures. So for example, if you have a wet towel and you just put it on a chair or something to dry, or even if it's cool outside, it will still continue to dry. It'll just take a longer time. Boiling, it's a more rapid form of vaporization. It occurs at a specific temperature, and that's called the boiling point. So for water, the boiling point is 100 degrees Celsius. So every substance that we know of has its own freezing and melting point. For water, the freezing and melting point of water is 0 degrees Celsius. All right, so I'm going to pause it here.